All right, our next section is going to be about solubility equilibrium. Will it dissolve? And if not, how much of it will dissolve? So all things that are dissolving are in an equilibrium. If there is not as much solid, it will all dissolve. As you add more and more solid to the solution, it will become saturated. Eventually become so saturated that some solid will go at the bottom. So this is when you go back between a solid and being dissolved. So you have a back and forth reaction going on. So we're in an equilibrium spot. So the solid will precipitate or turn into a solid as fast as it dissolves. So it will dissolve and go back to solid very quickly. This is an equilibrium state. So here's a general equation to get familiar with this. M plus stands for a cation. This is usually a metal, and then Nm stands for an anion, which is a nonmetal. Here's our general equation. You have Ma, this will be the number of moles of A, or how many you need to balance it, so our crisscross method, and then our nonmetal, B. This will always be a salt. This is going to be our salt, and then the reaction will go back and forth, and then this A is now our number of moles, and then we have M plus, and that will be an aqueous solution once it's dissolved, plus the number of moles of our nonmetal, or our anion, and this will also be an aqueous solution. So what we can do here is write an equilibrium expression. So we have K equals our products over our reactants, and they are raised to the number of moles. We've only just replaced A and B with our metal and our nonmetal, and then our salt. Or again, this is just written on top of each other, so it's a little bit clearer to see. We'll zoom in on that for a moment. So you have M plus A raised to A and M raised to B all over the salt. However, some of you guys might notice this was a solid. We cannot put solids in our equilibrium expressions. So, but the concentration of a solid does change. So, but the concentration of the solid doesn't change. I said does not change. So therefore our KSP will just be only the concentration of the ions inside of the solution. This is what we call the solubility product, KSP. This is the equation we're looking at right here. So let's look at some examples. So you guys have a table after this. I did not print it off. So we have AgCl, we have silver chloride, and this is its reacting going back and forth. If you look at your chart says something close to 1.8 times 10 to the negative 10th. This is again found in a table. So your concentrations for these are constants for specific salts. And we also have our lead chloride, lead 2 chloride, and its ions, and then we have KSP is going to equal to the ions times Cl squared. This time it's squared because we have 2 here, so therefore we have to have 2 here. And then this number again is found from a table. So let's go ahead and try a problem. If you're from an academic class, you guys can stop if you're listening. But if you're not honors, most of you guys just keep listening. So how can you calculate the concentration of an ion knowing that of the order? So what is the concentration of lead in a solution in equilibrium with lead chloride, and it gives us lead chloride's concentration? So let's go look at this a little bit longer term. So we have our concentration, KSP, equals the concentration of lead times the concentration of chloride. Again, squared because we looked at our reaction earlier where this reaction needs to be squared because there's 2 moles of it. So we're going to plug in our KSP that we know. It's 1.7 times 10 to the negative 5th. This is going to equal the concentration that was given to us for lead, which is 2 times 10 to the negative 2. Of chloride. Sorry, this is of chloride, not of lead. And we want to try and find the concentration of lead. So what we're going to do is we're going to divide both sides by 2 times 10 to the negative squared. So 1.7 times divided by this will give us our concentration of lead. Once we do that, this will be our answer. We can also determine the solubility can be determined by equilibrium. So this is going to be an equilibrium problem. So we want to calculate the solubility of SrSO4 with a KSP of 3.4 times 10 to the negative 7th. So what we need to do first is write out our reaction. Our reaction is going to be SrSO4 reacting to make Sr2 plus SO4 minus 2. So we're going to write our KSP. KSP will look something like this. And we're going to say Sr and SO4. There's only one of each of them, but their number of moles up here. So we're going to just call those X and X. When we dissolve them, their concentration should be the same. So it's going to be X times X. Once we times these together, we get X squared. And we were told our KSP. So I know our KSP is 3.4 times 10 to the negative 7th equals X squared. So to solve this, all we have to do is take the square root of both sides. Once we take the square root of both sides, this will be our answer for our solubility. Let's look at the next problem on our notes. We want to calculate the solubility of silver 1 chromate with a KSP of 1.2 in molarity. So here's our reaction. We're going to have silver chromate reacting to form, going back and forth, 2 silvers, and a chromate. So if we look at our KSP, we're going to have KSP equals Ag squared. This is very important because, again, we have 2 moles, so this needs to be squared. And then it's going to have times our chromate. What we're going to do is when we plug in X, we no longer just are saying we have 1 silver. We actually have 2 silvers, so we have to put 2x in here, and we do also have to square it. We have to do both. And then we're going to times that by x. So when we move on, we're going to take 1.2 times 10 to the negative 12 equals 4x squared, because we had to square the whole thing, times x. That becomes 4x cubed. And this is the KSP given again. So to solve this problem, we'll divide both sides by 4 and raise it to a 1/3 power to cancel out that cube. So you'll have 1.2 times 10 to the negative 12 divided by 4 raised to the 1/3. And to do that 1/3, you'll hit caret parentheses 1/3, and this will be your final answer. 6.7 times 10 to the negative 5th. And then just something we need to add here is the common ion effect. So if we try to dissolve a solid in a solution with either a cation or an anion already present, less will dissolve. This is basically saying that if you already have something dissolved, less of it will dissolve trying to dissolve something new. So if you already had salt dissolved in water, it would take less sugar to make it saturated. All right, make sure you're taking your quizzes. Thank you.